Today we're going to talk about the last procedure that we can use to solve systems of equations, and it's called elimination. Just a quick review, remember systems of linear equations are just when you have more than one line and the two lines kind of work together. In other words, their x and y values mean the same thing. So rather than just reading through steps 1 through 5 here, let's go ahead and do the process on some examples, and I'll refer back to the steps. So for example 1 below, let's look at step number 1. It says you need to stack the two equations, and they are stacked. One is right above the other. And make sure the x's, y's, constants, and equal signs are aligned. So let's do that. Notice your x's are in kind of the first column, your y's are in the next column, your equal signs are in the next column, and your constants are in the next column. So this equation does not need to be reorganized. So for step 2, sometimes you're going to have to multiply either one of the equations or both of the equations by a number so that your coefficients for one of your variables match each other except for having an opposite sign. So let's just look at this. So I want you to notice for the x's, one of the coefficients is a -3 and one is a -2, so they don't match each other. Now look at the y's though. Remember, if there's no number in front of the y, it's an understood 1. And notice what you have. It's a +1 and a -1. So here they match except for one is a positive and one is a negative. So watch what we can do. We're not going to have to multiply either equation. So step 3 here is we're going to add the two equations together so that the matching term is eliminated. Let's see what that looks like. So what we're going to do is we're essentially adding, kind of like you did back in elementary school if you had like 572 plus 123 or something like that, and you added columns together to get your final answer. It's kind of like that when we're dealing with solving systems by elimination. So if we add a -3x and a -2x, we get a -5x. For that second column, if we add a +1y and a -1y, well, what happens? A 1 minus 1 is 0. So what have we just done? We've eliminated the variable y for this equation. And then finally, we can add the two constants together, and 11 minus 6 or 11 plus -6 is +5. Now we have an equation that we can solve by just dividing both sides by -5. And we find that the value of x for the solution of the system is a -1. So remember, we're not finished because the solution to a system is an ordered pair. So at this point, what we need to do is exactly what we did when we were doing substitution. We're going to switch to substitution, and we're going to plug in, I'm just going to use the top equation. You're going to plug in the value for x back into one of the equations and then solve for the y. So instead of -3 times x, I'm going to say -3 times -1, and then plus y is equal to 11. Notice all I did is I replaced the x value with what I found the x value was. So now we just solve for y. So -3 times -1 is +3. I'll bring down the rest. Now to isolate our y, we're going to subtract 3 from both sides and find that y is equal to 8. And now we have an ordered pair solution of -1, 8. And we've solved. Okay, second question. First, we've got to make sure everything's aligned, and it is x over x, y over y, constant over constant, equal sign over equal sign. So we're in good shape there. The second step is we've got to make sure we have matching coefficients. And notice we don't. We have a 5 on for the coefficient of the x for the first equation and a 2 for the x on the second equation. For the y's, they also don't match. So we're going to have to multiply one of the equations, or both. Now, you've got some different options here. Like you could multiply the top equation by 2 or -2, and the bottom equation here we would need to multiply by -5 so that you have this one would become a +10x and this one would become a -10x. But it's actually easier if you make your y's match each other, because then you only have to multiply the bottom equation. So since this coefficient for the top equation on the y is a -8, we want to make the bottom one have a +8. So we're going to multiply the entire bottom equation by 8. So when we multiply every single term on both sides of the equal sign by 8, we end up with 8 times 2x is 16x, 8 times y is 8y, +8y, and 8 times -34 is -272. All right, now I'm going to just go ahead and bring down that top equation. It doesn't matter whether it's on top or bottom. You can rearrange them if you want to. So now we can just bring down 5x minus 8y is equal to 20 and add the two equations together. So 16x plus 5x is 21x. 8y minus 8y is gone. It's a 0y. So we've just effectively eliminated our y variable. And then -272 plus 20 is -252. And finally, to isolate our x, we're going to divide both sides by 21 and find that our x is equal to a -12. At this point, we can plug that value for x back in. to either one of the equations. I'm just going to go ahead and plug it back in to the top one. So we have 5 times negative 12 minus 8y is equal to 20. 5 times negative 12 is negative 60. Now I can add 60 to both sides and find negative 8y is equal to 80. We'll divide both sides by negative 8 and find that y is equal to negative 10. And finally, we'll write our final solution as an ordered pair, and that ordered pair is negative 12, negative 10. All right, moving on. So this one is one I wanted to show you because a lot of times we see linear equations in y equals mx plus b form, and students sometimes have trouble using elimination on that. I want you to notice that everything is stacked. We've got y's over y's, we've got equal signs over equal signs, we've got x's over x's, and we've got constants over constants. So we can still go through our process. So everything's aligned. Now we need to make sure that the coefficients on one of our variable terms match except for their signs. So notice we have them almost matching. Both y's have a coefficient of 1. So let's go ahead and multiply that bottom equation by a negative 1. And then we'll have not only matching coefficients, but opposite signs, which is what we want. So we end up with a negative 1y is equal to a negative 2x plus 1. Notice we went negative 1 times negative y, or times 1y, negative 1 times 2, and negative 1 times negative 1. And that's where we got that plus 1. So I'm going to go ahead and bring down that top equation again, and I'll have a positive 1y is equal to 3x plus 4, and we're going to add the two equations together. So negative 1y plus 1y is 0. We've eliminated that term. Now, just so that you don't get confused, I would recommend going ahead and putting a 0 there so that that side isn't just completely blank. So let's go ahead and move to the other columns in our system. So we've got negative 2x plus 3x. That would just give us a positive 1x, and then a 1 plus 4 is 5. Now we want to isolate our x value, so I'm going to subtract 5 from both sides, and I find that negative 5 is equal to 1x, or I can just say x. We've solved for our x value. So now we're going to plug back in to find the value of our y. So it doesn't matter which equation you plug back into. I'm just going to plug into the top one. So I'm going to have y is equal to not 3x anymore, but 3 times negative 5 plus 4. And we simplify from there. So 3 times negative 5 is negative 15. Negative 15 plus 4 is negative 11. And finally, we write our solution as an ordered pair. So negative 5, negative 11. And now the last one. This one's got some big numbers in it, and none of our coefficients match. So just make sure you're careful on your arithmetic. Maybe check your arithmetic with a calculator. So first, make sure everything's aligned, and it is. X's over x's, y's over y's, equal signs over equal signs, and constants over constants. So we're good there. Notice we don't have any coefficients that match. And in fact, we can't just multiply one of our equations by a number to make them match. We're going to have to multiply both of the equations by something to make them match. Here's what I decided. I decided that I was going to eliminate my y variables. You can choose to eliminate your x's instead if you want to. Either one is fine. But a way to get your coefficients to match is by multiplying the top equation by the coefficient of the bottom one, and then the bottom equation by the coefficient of the top one. Now, notice they've already got opposite signs, so I'm not going to multiply by a negative 3 or a negative 14. I'm just going to keep them both positive. Okay, so for that top equation, we're going to multiply everything by 14. Don't forget, every single term on both sides of the equal sign. So we're going to end up with 14 times 15, which is equal to 210x. 14 times negative 3 is negative 42y, and then 14 times 75 is 1050. Now we'll do the bottom equation. 3 times 7x is 21x. 3 times 14 is a positive 42y. And 3 times negative 42 is negative 126. Notice what we've just created. We've created a term where the coefficients match, but the signs are opposite. So now, when we add the two equations together, we can eliminate our y variable. So 210 plus 21, that's going to give us a 231x. Negative 42y plus 42y is 0. Bring down our equal sign, and 1050 minus 126 is 924. It's about to get a lot nicer. We're going to divide both sides by 231 and find that x is equal to 4. Now that you have one of your variables solved for, we're going to plug back into either equation and solve for our y. So I have a little bit smaller numbers on the bottom equation, so I'm going to go ahead and use that one. So instead of 7 times x, I'm going to say 7 times 4, then plus 14y is equal to negative 42. And now I simplify and solve. So 7 times 4 is 28. I'll bring down the rest. Now I can subtract 28 from both sides. From there, we can say that 14y is equal to negative 70. We'll divide both sides by 14 to isolate our y and find that y is equal to negative 5. And our final answer written as an ordered pair is 4, negative 5. Now, I want to show you one other thing you could have done on this question that would have worked and made your numbers a lot nicer. What if instead of initially multiplying the top by 14 and the bottom by 3, you divided the top by 3? Notice if you did that, then you would have gotten, if we divided everything by 3 on both sides of the equal sign, we would have gotten a 5x minus y is equal to 25. And then your numbers would have been smaller, and you could have multiplied the top equation just by 14, and then the bottom equation would match after that. If that didn't make sense to you, it's okay. It's just an alternate way to do it. And what we did is completely legitimate, just big numbers. Okay. And finally, let's do a practical example. So it says Natalie is filling Valentine's Day candy graham bags with gumballs that cost 10 cents a piece and lollipops that cost 15 cents a piece. If the bags will all have a value of $2.25 and a total of 20 pieces of candy, how many of each type of candy should each bag have? Now here's the key. Let's define our variables. If we define our variables, remember the last sentence of the question a lot of times will tell you a clue to what those variables are. Notice it says how many of each type of candy. Well, there's our variables. One of them is how many or the number of gumballs, and one is the number of lollipops. Here's the key too. If you have two unknown variables, then you need to have two equations. So if at any point you have two unknown variables and you're having to solve, then you need to try to find two different equations to help you solve. There's two different ways we want to look at these candy graham bags. One way is just how much is in it, and one way is how much value does it have. So if we just talk about how much is in it, it's 20 pieces of candy. Think about how you would get the total number of pieces of candy. You would take the number of gumballs and the number of lollipops and add them together. What does that look like algebraically? X plus y is equal to 20. There's one of your equations. Really nice and simple and not too hard to work with. Now the second part is a little bit messier, but it's dealing with money. So we want a total value of $2.25. Well, think about how you would get that. You would do 10 cents times however many gumballs are in the bag plus 15 cents times however many lollipops are in the bag. And now we have a system of equations. They're nice and stacked, so we can fairly easily solve using elimination. Now, because we're dealing with money, we've got decimals involved. So if you want to immediately get rid of all of your decimals and you're dealing with money, just multiply everything by 100. Or that means you're going to move your decimal 2 places to the right. So instead of 0.10x and 0.15y is equal to 2.25, you end up with 10x plus 15y is equal to 225. And a lot of students like that better. And then I'm going to go ahead and make our x values match each other by multiplying the top equation by a negative 10. So remember, distribute the negative 10 to every single term, and we'll have a negative 10x minus 10y is equal to a negative 200. Now if we add the two equations together, 10x plus negative 10x is 0. We've effectively eliminated our x. 15y plus negative 10y is 5y. And then 225 plus negative 200 is 25. Now we divide both sides by 5 and find that y is equal to 5. Now, to find our x variable, we're going to go back and plug in our 5 in place of y. So instead of x plus y equals 20, we'll have x plus 5 is equal to 20. Subtract 5 from both sides and know that x is equal to 15. And finally, written as an ordered pair, our solution is 15, 5. What does that mean? It means the bags have 15 gumballs and 5 lollipops. And that not only reaches the goal of the value of the bags, but also the number of pieces of candy.